So today we are going to talk about collections, like how to handle collections, and when you are using Hibernate, like you can have a table, and its a primary key can be a foreign key on a different table. Like relationships between tables can exist in SQL, right? How to deal with that in Hibernate is one approach that we are going to look at today. So, topics that we are going to cover are understand collections and association relationships, and see how to realize relationships in Java and databases. Walk through Hibernate approach of mapping associations. Okay. So, what is an association? Like, it's just the relationship between, say, for example, account and account owner. Like the relationship is account is owned by an account owner, something like that. So there is some relationship there. So that means any account that we see, whether it's a checking account or a savings account, will definitely have an account owner, right? So, and a account owner can have more than one account, right? Like I can own a checking account, I can own a savings account, credit card account, and all that stuff. So how do we map it? We just have that one account owner, and we take account owner ID, like we just map that account owner ID to an account. So this account owner table is like a join table if you think about it in SQL. Like you have an account table, you have a owner table, like people table. You will have one join table, like account and owner ID join. So it can be many to many, like any account can be associated to any owner or more than one owners, right? So in terms of joint account, if you think about, so are you guys following the context where I'm getting into? Like if you have many to many relationship between any two objects, so if you are in SQL world and if you are in RDBMS, you know how to deal with it. But if you are in Hibernate, how to deal with it is the takeaway for today. Okay. So association, mapping relationship between two objects. Example, account and account owner. And collection of collection already, like collection of values representing individual pieces of data is called a collection. That means if you have an object of string, if you have a collection of string, that means you can have an array list of a string or a linked list of a string and all that stuff, right? So that is called a collection of pieces of data. Like you can have map of holidays or a string array of months and everything. Then relationship dimensions. So like how this relationship can be identified, and on what basis we can say like these two are related. Okay. So that is called dimensions, relationship dimensions. Relationships between entities can exist in multiple ways. Like it can be multiplicity, just now I said one to many, right? So one to many, many to one, or one to zero to many, all these are called multiplicity. That means how many on each side of relationship. That means one account one account can be owned by many account owners. If you are considering a joint account, one account can be owned by more than one account owner. So multiplicity of it is one to many, yeah, in terms of account and account owner, right? And when you talk about account owner to account owner can also have multiple accounts, right? So if you consider the multiplicity from that direction, like there are, like I'm talking about direction also there, right? But forget about direction. But if I'm talking about an account owner and an account owner can have more than one account, right? So that is like from one account can have zero to many accounts, right? So that is called multiplicity. How many on each side of a relationship is called a multiplicity. Directionality is like how I said. Okay, an account is associated to an account owner. An account owner is associated to an account. So if you come from that direction, an account owner is associated to an account. If you are talking about um, account direction, an account can be owned by more than one account owner. So that means you can have two different directions for a relationship. Why are we worried about two different directions? Think about it like a Java class. Account and account owner, two different .java classes are there. So given an account object, you can get account owners. And given an account owners object, you can get account. So that's the flexibility. If you have bidirectional relationship, that means account is associated to an account owner, and account owner is associated to an account. You have a bidirectional relationship, and either one of the object handle you have, you can get the other details. Okay, that's why directionality is important. Are you guys with me so far? Is it making sense? The conversation so far?
Yes.
Okay. So relationship multiplicity. So what are the kinds of relationships that we have? One to many. A single account has many transactions. Reverse of many to one is nothing but one to many. So forget about reverse of many to one. You guys know already. Like a single account. Think about it like this: one to many. A single account has many transactions. Many to one, multiple transactions belong to a single account. And if you just simply think about it, this one to many we are talking about is from the direction of account, right? One account can have many transactions. If you think about it, like account and transactions are two different entities. One account can have many transactions, and reverse of many to one, like multiple transactions belong to a single account, right? And one to one, a single account owner has a single home address. A single home address has a single account owner. But this can be relative, right? If I have home address, I'll have only one. If I have more than one home, if you start talking about like, oh, what if I have more than one home address, which is very unlikely. Like people always have one home address, one office address, and stuff like that, right? But unless that person is actually working in multiple places and staying in multiple places, few days here, few days there, then it's a different story. But for this modeling purpose, what we considered is, okay, one account owner has one home address, and a single home address has a single account owner. Okay, so here one to one we are talking about it as a home address. Or for example, um, what else we can consider as one to one in real life? Yeah. What else we can have? Cars. We can have many homes. We can have many. I think this example speaks for it. Like a single account owner has a single home address, and a single home address has a single account. That's when it is bidirectional one to one. Like both sides of the relationship, if you look at it, it's one to one. Then many to many. Like multiple accounts have, this was the relationship I was talking about, right? It can have a joint table, and it is like many to many. Like multiple accounts have multiple account owners, and often realized through one to many relationship. Or a single account has multiple account owners, a single account owner has multiple accounts. This was the one we discussed in the beginning, right? So those kind of relationships, we, if it is one to many on both sides, we just say many to many. Like a single account has multiple account owners, a single account owner has multiple accounts. So that means if you look at both directions of the relationships, it is one to many. So that's when we say like many to many. Making sense? Are you guys any questions on any of these four multiplicity? Did you guys follow so far?
The account has many transactions and multiple transactions belong to a single account. That comes to many to many.
No, that is actually many one to many and many to one, because same transaction cannot be from more than one account, right? In this case, if you think about it, here in the last place, a single account owner, like if it I have a checking account, and also I have another mortgage account. My wife is also joint account owner with me. Okay, say for example, if I have that situation, if you are thinking about a mortgage account perspective, there are two owners, me and my wife, right? So that means from that perspective, it's it's one to many. And in the same way, if you look at it in any of our my perspective or my spouse perspective, one account owner, like I'm an account owner, I'm associated to checking account, credit card account, mortgage account, and n number of accounts, right? So that's why, and if you look at it that way, I am one to many even from that side. That's when we say many to many. But here, in this case, where you asked one to many, a transaction cannot be from more than one account, right? It has to be always associated to a single account. It's actually a part of your account, right? Um, it cannot be from more than one account. It's like a representation of same transaction can be from two different accounts. For example, you are transferring money from your savings account to a checking account. It is actually two different transactions, and each transaction is owned by one savings account, one checking account, right? You see what I'm saying? Like I did
Yeah.
a transfer of $100. It has to do a debit on a checking account and credit on credit on a savings account, right? So that means these are two different transactions, and each transaction is associated to a particular account. So now think about it in that terms. Okay, I am looking at a transaction of checking account. Okay, and when I look at a transaction of a checking account, how many it is always associated to one account. It's not associated to more than one account. Maybe details of a transaction can have savings account details or destination details and source details and stuff like that if it is a transfer, but it need not be the case for all the transactions, right? So it is like one to one in terms of transaction perspective. Like there can be many transactions associated to one account. Okay, many transactions associated to one account. And if you think about it from account perspective, one account has many transactions. um, did it make sense, or did it confuse you a lot?
The many to one confused that.
Okay,
It's simple.
still not following how many to one it is.
Uh,
Yeah. uh,
how it is not many to many. I am not following that.
how it is not many to many.
Yeah.
Okay, so here is the thing. In bidirectional, okay, so I understand what you're saying. um, okay, if there is a need, okay, think about it in an SQL perspective. Okay, then probably it makes a little more sense. Mm, you have a primary table, account table, okay, and you have a transaction table. Okay, um, if you created an account transaction table, okay, if you created an account transaction table, then it's many to many. That means you created a join table, which makes you think like, oh, many accounts can have many transactions. Okay, that means one account can have multiple transactions, and one transaction can be part of multiple accounts. But in terms of accounts and transactions, this can never happen, right? Do you see what I'm saying? Like uh, you have an account table and account transaction table. Okay, means a primary table and a secondary table. You have a account ID's foreign key, primary key as a foreign key in account transaction table, right? So what you do there, given an account ID, you can get list of transactions. Okay, but given a transaction ID, you will get only one account ID. You'll not get more than one account ID there. Are you following so far? Think
Yes.
of, okay. This is primary and foreign key. This is called one to many. If you are referring to one account can have many transactions, and if you are looking at a account transaction perspective, that means you looked at one account, one transaction, and you got only one account ID. You did not get multiple account IDs looking at one transaction, right?
Yes.
That is called one to many from account perspective, and there can be many transactions associated to one account from a transaction perspective. Are you clear so far? Probably you were
Yes.
clear about this before also, right? Okay.
Yeah.
Then many to many. Many to many is in such a way, like if I created a join table, okay, if I created a join table called account underscore transaction, like given an transaction ID also, I should be able to get multiple accounts. Okay, so in this situation, account and transaction, that cannot happen. So that's why think about it now in terms of account and account owners perspective. Okay, go back to the example that I gave. Okay, now you have account table, account owner table. Okay, so SQL, and where we don't want to duplicate data, right? In SQL, idea is what? Relational database management system. Rules of normalization is you should not be able to duplicate data. Have list of owners, have list of accounts, right? And then create a join table. Like, see, for example, here, why do we have to create a join table? Would be the question for you, right? Let's answer that. Okay, I have an account, checking account. Fine. I have an account owner ID because I am unique, right? I am unique. Account owner is unique because I my details will not change. Though I have 100 accounts, my details will not change, right? So I have an account owner ID. Fine. Looking at an account perspective, either I can be one account owner for an account, checking account, or I can add my spouse also to that. So if you look at one account ID, I can have one or more than one account owners. Agreed so far?
Yes.
Right? Okay. Now think about it in a different term. Like, okay, I want to know list of all accounts an account owner owns. Okay. If you look at my Bank of America profile, okay, how many accounts this person holds? If you want to get that kind of data, given an account owner ID, you want to get the list of all the accounts he owns, right? So that means if you know the owner name also, you can get the list of accounts. If you know the account ID also, you can get the list of owners associated to it. That means it is a list on both sides. You see what I'm saying? Now,
Yeah.
in terms of SQL, given an account ID, I will get one or more than one rows. If I just have an account table and account owner table, I cannot get this, right? I cannot get this happening. So for that, what I do is I create a join table called account underscore transaction, and wherein account owner ID 1 has checking account 191. Account owner ID 1 has savings account 192. That's one way. And given an account owner ID, like given an account owner ID, you can get list of accounts he owns, and given an account ID you can get list of owners associated to it. Say for example, my account ID 191 has me, account owner ID 1, and also my spouse as my account owner, joint account owner as 2. So that means I have both, right? Like given an account ID, I can get both the account owners. Given an account owner ID, I can get list of all accounts. That means anytime you're getting for a given ID, where the output is a list which has one
Okay.
or more, like where there is a possibility of one or more, then we say one to many from that
Okay.
side. And also, if you look at it from account and account owner, one to many on that side. If it is one to many on both sides, then it is called many to many. Did it make any sense this time?
Oh, yes.
Yeah, it's complicated. Just feel free to ask as many questions as possible. And here you need not know Java also. It is like real time, right? You are talking about real time. If you know what an object is, you're good to go, right? So feel free to ask as many questions as possible. So relationship directionality. So what is this? So as we said, okay, if something is related only one side, like say for example, can only traverse objects from one side of the relationship. From account, you can get a transaction. Given an account object can obtain related transaction objects. Given a transaction object cannot obtain related account object, then that is called unidirectional. Say for arbitrary case, okay? But can traverse both sides of the relationship. Say for example, given an account ID, you can get list of all transactions, and given a transaction object, you can obtain a related account object. Then it is called bidirectional relationship. Do you know the difference now? What is unidirectional and what is bidirectional? So we said, okay, one to many or
Yes.
whatever relationship. So given one, you'll get all the other stuff, and given the other one, you'll get all the like say given a transaction ID, you get list of all the account details. Given an account ID, you get list of all transactions. Then it is called bidirectional. Okay. So realizing relationships. Now the questions that are running in your mind is like how to realize these relationships, right? So Java objects are inherently directional. An object has a reference or a pointer to another object. So in database, if you are familiar with the database and if you have attended our joins and all that class, you know, right? Relations are not inherently directional. So a table can arbitrarily join its columns with the columns of the other tables, and the way how we join them is nothing but a relationship. Okay, in Java you want to map relationships between objects, whereas in database you want to map relationships between the parent table, like join tables, creating join tables, as I said, account underscore owners, or primary key foreign key relationship and stuff like that. That's how you realize the relationships. So relationships in Java, object has like if you think about it.
Ravi?
Yeah,
Yes. One quick question. Um, Unidirectional is one to many, and bidirectional is many to many, right?
yeah. If you have one to many on both directions, then it is many to many.
Then it is bidirectional. And unidirectional is one to many and many to one.
It can be anything. Like it can be many to. If it is many to one on both directions, or if it is one to many on both directions, you will say many to many. Yeah, you can think about it that way. Yeah, you can take it that way. Yeah, that makes it simpler.
Means one to many because we are taking uh, okay. Unidirectional is only one from one side relationship, right? We can obtain the information from one side, right?
You can get information only from one side. Yes, that is unidirectional. Yeah.
Okay, thank you.
Okay. So object has an attribute referencing another related objects. For many side, like one to many is there, right? On the many side of the relationship, say for example, account and account transactions, we said many, right? That means in the account object, you can have set of collections, you can have a map of collections, you can have a list of collections, and you can have array of I meant to say set of transactions, map of transactions, list of transactions, and arrays of transactions. Okay, so relationships is you can have set given an account object in in account.java. One of the properties you can have is set of transactions, map of transactions. Either of these you can have. That shows you, oh, okay, so it is one to many between account and account transaction. So all it boils down to is how you write it in Java code, right? So relational database has it already. This primary key foreign key relationships. Now with Hibernate, everything we are dealing with is no SQL code, right? SQL code is generated by the framework. So that means you want to like SQL code is generated by a framework. So now you want to actually do stuff like actually do the uh, modeling on the Java objects. So that's how you use this set, map, list, or arrays. Okay. Then relationships in databases. So in our RDBMS class, we talked about denormalizing. When we do denormalizing, when the data is getting duplicated, and if you have too many columns, what is the rule of normalization? Is like make it into modular table and have like a primary key foreign key relationship. So that means you're going to denormalize, like record repeated in the same table each time capturing different data. So you don't want to have that. You don't want to repeat data at any point of time. Remember, you don't want to repeat data. That repetition I meant is, say for example, mm, account information, like account owner information is captured in a single table, say suppose. Then I have a checking account owned by myself and my spouse. Entire account data is all duplicated. Only thing that changes is account owner information, right? Because both me and my spouse are part of it. So if you put it in one single table, it's like duplication of entire account information, and only account owner information changes. So instead, if you have two tables, account information is unique, account owner information is unique in a different table. And now if you have an account owner relationship table, then what we'll have is an account id and an account owner id associated to it. If there are like two account owners, one account will have two account owners associated to it, and you are done. That way you're not actually duplicating data. Making sense so far? So that is what is called like denormalization, means everything keeping in one table. Whereas if I have normalized it, that means I have three tables in terms of account owner relationship modeling. Making sense? Are you guys with me so far?
Yes.
Yeah. Okay. So that's when denormalized tables are there. Then foreign key primary key relationship is there, just like how we talked just now. And also join table as account owner relationship table, and ad hoc joins in a query. So you can have ad hoc joins in a query. That means arbitrary joins between columns. Like if you are writing in a SQL query, you join it on primary key and foreign key or something, and then you actually not just primary key foreign key. You want to determine more, like how many people from Fremont zip code registered to my application, or how many people who are registered are male or female. Like you want to write some ad hoc queries. So those ad hoc queries and arbitrary joins that you write can also be part of relationships in the database. And each of these techniques has its pros and cons. Okay, but yeah, they were also talking about relationships in tables, like a denormalized table. Are you able to see it, or do you want me to zoom in a little bit more? Can you see the table data
A little bit.
a little bit more?
I want maximize.
Uh, okay, is it fine now?
Yes.
Okay. So denormalized table. What is denormalized table? Look at the data here. Whenever you're dealing with databases, look at the data before you even derive anything from it, or even if you write SQL queries and all that. Before that, just look at the data once. Denormalized. If you look at the customer name, it's always customer one, and customer phone, and customer address, contract name, Home Depot. Only thing that is changing here is contract price. Do you see that? First two rows I'm talking about. Contract price and start date. Those are the only two ones that are changing n number of times. Instead, we could have had customer and contractor as two different tables, and you could have had customer contract as a join table, and you wouldn't have duplicated bunch of data. Do you see what I'm saying? Are you guys following what I'm talking about? If you look at first two rows,
Yes.
yeah, first two rows, you just have customer one. Yeah. Okay. So here the pro is very fast, easy to query against, contains redundant data. Redundancy means repetition. Okay. And repetition with no value is redundancy. and requires many null columns. Like as the columns grow, only it may be associated to one of the record, but it may not be associated to other record. So you may end up putting in lot of null columns. Okay. Then relationships in database, foreign key relationship that you guys are aware of. Say for example, employee and health plan. Like employee is associated to a health plan. So if health plan keeps changing, but it is associated to an employee. So that way you can change only in health plan place, and it can be associated to employee. Okay, it's easy to maintain also. So it reduces redundancy, better modeling of data, slower than denormalized. Anytime you introduce a join, data fetching will be like it does the Cartesian product a into b, and it joins all the tables of all the rows of a and all the possible combinations from a to b. Okay, and slightly more complicated to query against, because you need to know a little bit of how the data works before you write the query. Okay. Relationships in tables, databases. Okay, what is a relationship? Join tables. Okay, as we initially thought, the moment I looked at the data, I told, right? So it's like a customer, contractor, or a contract. So that means customer data is here. If something changes in the customer data, you're going to modify only the customer object. Contractor is there. If you want to modify anything in the contractor, you're going to modify only the contractor information. Here it is just the association. Oh, this contract is associated to this customer. That's all. And what is the price and start date. So this would be even more better. You don't need to have any changes. It's just the relationship that you are maintaining in here. And delete of this contract relationship will not affect contractor or customer. You're still going to maintain those two informations in your database. Okay. Slower yet even more complex query, but built on foreign key model enables many to many relationship. So if something is like an employee is associated to more than one health plan, it is one to many relationship. Okay. And if customer is associated to a contractor, okay, like here it is many to many, because contractor can be associated to many contracts, customer can be associated to many contracts as well, right? Many contractors, like I can hire many contractors for my building, and one contractor can work for more than one place, so that is called many to many. So if you guys are thinking about how to identify, as Rini asked before, how to identify, um, before looking at what I'm trying to say is, one to one can also be bidirectional. Okay, one to one can also be bidirectional, and one to many cannot be bidirectional. It's like if it is one to many from both the sides, then we end up in the many to many thing, right? So you can have one to many and many to one, and but still the relationship can be bidirectional. Bidirectional in the sense, you given an object, you are going to get the relationship data itself also, or given a relationship data, you can get the owner data also. Okay, and you can have one-to-one bidirectional. That means home address, given an account owner and his home address. Given in a home address, you can find his given you can find the home account owner also. That's like bidirectional. And one to many, many to one, you guys understood from account transaction thing. And many to many is remember this particular analogy, like customer, contract, and contractor. Okay, so any questions so far on how to identify? Are you clear, like how to identify between objects? Like if you have a relationship, okay, like if you can traverse from both the sides, then it is bidirectional, otherwise it is unidirectional. But one to one can also be bidirectional, is what I'm trying to say to you guys. Okay, so one to many, many to one, and one to one, it can be bidirectional. So this one to many can, if it is bidirectional, we say many to many. Okay, just like think about our contractor and contract. and customer. Okay, and then one to one, one to many. Think about it like account and transaction model. Okay, probably if somebody asks in the interviews, do remember this analogies. Probably that's when it's easy to explain and defend yourself if they ask more questions on top of it. Okay, let's move on. Okay, so now that we saw all this, right, relationships in tables and all that, so join table, we saw pros and cons with each of these. And then relationships in database. Pros allows for any possible query a user can think of without having to predefine the requirements in the schema design. So you can do down the line also. When you are actually designing, you may not know what query you want to write, but subsequently it helps you to write more queries, right? In the same consequence, no model enforcement can join age and floor later to the customer. Like if you want to add more and more more and more columns to customer object, you can add. Nobody is going to object because outside world of customer is going to just care about customer ID. Okay, and can be complicated or confusing to write. Results may not appear as desired, but that's not the case. Like I like joins. Those are complicated, but they give you a lot of flexibility to fetch the data. Like if you did not understand the data and if your modeling is not right, yeah, you may end up in troubles. But if you have right modeling and right indexes added on the tables, joins are good. Okay. So for example, in this query, what they are trying to get is a contractor uh, where the contractor state is from customer, where customer name is John Smith. So that means we want to know the contractors, like a list of all contractors in the state where John Smith had his contractor from. Like John Smith is a guy who's is a customer. He had a he resides in a particular state. Okay, like say California. So we want to know, okay, wherever John Smith is, I want to know which state he lives in, and I want to fetch contractors in that state. Okay, this is called actually a subquery. Like you query, you get the result set out of this query first, and then run this query based off of the result set that came in out of this. Okay, so these kind of queries that you can think about later is what they are talking about. Like if you have joins, you can think about queries that come up later also. Okay, so realizing relationships with Hibernate. Okay, now that you guys understood what is how it does on how it does in SQL world, how to identify the same in Hibernate. Domain object graph models. Hibernate represents domain object relationships through a graph, object graph. This is all relationships between the objects, right? So that's why this is all called object graph model. Okay. Bidirectional relationships require graph model updates for objects on both sides. Okay. Bidirectional relationships require graph model updates for objects on the both sides. So that means A is related to B and B is related to A. That's called a bidirectional relationship. And need to keep all in memory objects up to date. That means Hibernate maintains everything in the memory before writing it to the database. So it has to update all the relationships. If it is bidirectional, it may be slow. Like if you change account owner information, account should also know that, oh, account owner object got changed. I should not have a stale data. I should update that as well. Like that. Okay. That kind of complexity is there. So if your object A and B have a bidirectional relationship, and object B is added to object A, need to make sure that object A also get added to object B. So that's the thing. Like if a new object is been created of type A, and if you added that to memory, then you may end up adding that to B as well because it's bidirectional relationship. So B also should be aware that a new A has been created. Okay, can cause complication when persisting the relationship. Which side should save the relationship and stuff like that. That means if you have a bidirectional relationship, you should specify who is the owner of the relationship. Okay, that means owner of the relationship takes care of all these maintenance of the object graph. Is it like too much technical jargon, or are you guys following with me? Like You guys followed what an object graph is and how Hibernate needs to update, why it needs to update. Did you follow? Are you guys with me? Basically, that is my question. Are you guys with me or lost somewhere? Do you have a question?
Why we need that update
Why do
when
we
we are
need?
adding a new object?
Yeah, because otherwise, okay, you created an account owner, okay, and you created an account. Now, account and account owner both are still not persisted yet, okay. So you created an account object and you said, okay, account dot set account owner. Fine. That means account object knows there is a new account owner. And the account owner also should know, oh, there is a account new account associated to my account owner object, so I need to update my relationship also. All I'm talking about is, okay, you have two bags. Okay, think about it like this. You have two bags. One is associated to an account, another one is associated to your account owner. Okay, so given an account ID, you should know list of all account owners. Given an account owner ID, you should know list of all account objects, right? So you need to update both. Otherwise, uh, otherwise you may not know. Given an account owner ID, which account it is associated to. Given an account owner ID, you may not know account ID, and given an account ID, you may not know which account owner it is associated to. Am I confusing you?
No, I got.
Yeah. So because these are all memory graph, right? Until it actually writes to the database, as we saw in our last class, session dot save or update, it is not writing to the database until then, right? It is all in the memory. Once we said session dot save or update it and commit, that's when it is actually writing to the database. So till then, it's all in the memory, and all this memory graph needs to be updated, and you got to model it properly. Otherwise, it may get confused. And to avoid all these confusions, who is taking care of these updates, right? Who is taking care of these updates? Uh, owning, like if you are bidirectional relationship, owning side of the relationship, whoever is owning the relationship, they will take care of all these updates. Okay. How do we specify the owning side? Like if you say like A and B, okay, A is associated to B, B is associated to A. Either object A having a object B or object B having an object A. One of these guys will be owning the relationship and they'll take care of all these updates and saving to the database and all that stuff. Okay. So let's see how to mark a side as a saving side or owning side. Okay. So what do you do? Inverse attribute used for both one to many. Okay, one to many or many to one and many to many relationships. Inverse, if you put an inverse attribute, that's like the owning side. Say for example, for one to many or many to one, usually placed in the mapping file of the single object side of the relationship. And for many to many, one side of the relationship, like if id bag is used, must be on the non id bag side. Okay, that means um, so it should be on the other side. Like let's see an example. That's when probably it makes more sense. Property ref attribute used for one-to-one relationships, either side of the relationship but only once. Okay, so let's see, like let's see if I think with an example you guys will be a little more clear. Okay, before showing the relationships, let me actually show an example in the code that actually helps you. Okay, so look at it here. Okay, so here, given an account object, I have list of account owners, right? List of account owners. And look at an account owner object. I have list a set of accounts. Okay, fine. Why we have list and why we have set? You guys have to answer that. Actually, here we don't have a list, we have a collection, but the object is our list. What is the difference between a list and a set? Very important interview question.
Set doesn't allow duplicates. List it has ordered.
It has the
Things
order
ordered
and
in
also
the
it
list.
allows the duplicate. Yeah, that's right.
And cannot have duplicate.
What is it?
List cannot have duplicates.
List cannot have duplicates?
Yes.
List.
Yes.
Can have duplicates.
Are you sure? List cannot have duplicates. Can you justify? What is a duplicate? Are you here? Do you want to answer? What is a duplicate?
Duplicate data.
Duplicate data. Doesn't it map to an object? So duplicate objects, you're saying. So list cannot have duplicate objects. How to
Maybe
enforce?
wrong. Maybe wrong. I don't remember right now. It's okay.
Okay. Fine.
Yeah. No, I think so. It allows duplicate. I just got confused. That's it.
Okay. Just to restate, set does not allow duplicates. List allows duplicates. That's the primary definition of any list or a set interface. But within a set, you can override your equals method, like object equals method. If two objects are not equal, then it allows the same data, but something within that should be different. So that's when it adds, like Ravi Nukala, employee ID 1, everything can be added as duplicate, but something in between those two objects should be different and makes like a dot equals method false between those two objects. That's when you can see two different two objects added to the list, but you got to override equals in such a way those two objects are not equal. That's when list can hold objects for a same person, but you really have to tweak your equals method to actually add duplicates. But we wouldn't do that, but I'm just making up, and interviewers may trouble you asking that. Did you follow what I said? Like how you can override equals and add data to set, and that can be of the same person. Data can be of the same person. Override equals in such a way that always returns false. Big deal, right? If you just do that, you can add any number of stuff, right? Any number of things to the same set. That's okay. So any question?
No.
Oh, okay. Fine. So that's how you had these relationship. So it is on both sides. So you have bidirectional relationship. Good. And here between account and account transaction. So account transaction doesn't have, okay, it has an account object, right? And account does not know anything about transaction. Oh, it knows. See here. Account knows about transactions. We have list of accounts, account transactions within an account, and account transaction can be associated to an account. This is actually many transactions can have one account, and one account can have many transactions. This is one to many, we know, right? So with these in mind, let's look at how we created our config files. Okay, so look at account hbm.xml and account owner hbm.xml. Why we are looking at hbm.xml? This is where mapping between a table and a object exists, and any relationships that you have to deal with also will be there in the same XML. Today nobody is using XML approach, but we started with XML approach and moved towards annotations. Okay, annotations like one to many, many to one, and all that stuff, but we'll talk about them later. Understand the concept first. Okay, so here is the thing. You have an account object. Okay, and you have all the properties listed here, right? Look at account transactions property, like sort is natural. You said inverse attribute true. That means when you set inverse attribute true, this is the owning side of the relationship between account and account transaction. Account transaction is the owning side. That means account object is the owning side of the relationship. So this has to take care of updating any bidirectional relationship and all that stuff. Following so far? Are you guys with me? Can you guys hear me?
Yes.
Yeah. So inverse true is nothing but the owning side, which wherever you say inverse equals to true. And account owner hbm.xml, if you see, you have account owner last name, first name, social security number, address, and you have a parent as account number, account owner. Okay, and you have account owner data as a set. Okay, so here we did not specify. See here. Here we did not specify accounts, account owner ID. Okay, so table is account owner, set is a list of accounts, and we said inverse equals to true. Okay, here also we specified, right? So, but what is that we are referring to here? Um, oh, we were talking about transaction, right? We were talking about transaction. So just don't get confused like me. Don't open account owner. You have to open account transaction model. Okay. So here we are looking at relationship between account and account transaction, right? So that's why I opened account transaction. Previously I opened account owner. That's why even I got confused. So if you look at account hbm.xml, you know the inverse is true. That means this guy is owning the relationship. If you go back here, you will not see that. Do you see here what I'm talking about? We said many to one. That's it. And here we did not say inverse equals to true, right? Here we said inverse equals to true in this side, right? Here we said inverse is not. We did not specify anything about inverse. Okay. Now let's get back to this one. Here what we said, inverse attribute marking the saving side. Wherever inverse equals to true is exists, that guy is going to own the relationship and take care of saving and everything. Okay, saving and everything. And property ref attribute used for one-to-one relationships. So where we had a one-to-one relationship in between account and home address or something, right? Let's see. Account has address, right? Account has address, and here we did not specify anything else, right? Property ref is not specified here. Do you guys see what I'm talking about? Account owner. This is account owner. And where do you see home addresses? Composite element, street address, all this stuff, right? So I want to show property ref also. Let's see here, address. We don't have anything like any other address stuff here, right? So let's see property ref if we have that attribute anywhere. I'm just searching all the XML files that I have. Okay. Oh, looks like we have it. Okay. Oh, good. So we have account transaction, and there is a one-to-one relationship between e-bill. Okay. That means here we are saying like, oh, okay. So account transaction, e-bill, property ref, meaning name of this attribute is account transaction. If you go to e-bill object, ebill.java, here you have a transaction. So that means transaction attribute. Okay. So if you carefully look at it, account transaction.java. Sorry about that. If you are getting confused, just bear with me for one more moment. You will be clarified. So you have account transaction. Within that, you have a e-bill property, right? So now look at account transaction.hbm.xml, right? Account transaction.hbm.xml. You have e-bill property mapped to e-bill object, and property reference in that e-bill object is account transaction. Okay, so that means if you go to e-bill object, account transaction is specified as account transaction, right? This attribute. So we just put those two names. Okay, so we put the name in this object, account transaction object, and we put the name in the e-bill object, and we put the class name or e-bill. Okay, that's how you can specify the relationship. And if you go to ebill.hbm.xml, if you go to ebill.hbm.xml, you will see account transaction. Okay, account transaction as many to one and all that stuff, but it doesn't talk about in property ref. Okay, whoever owns property ref is the person, is the object that takes care of saving. Okay, in terms of one to one, we say property ref. In terms of one to many, we said in terms of one to many, what did we say here? We said inverse, right? He is going to take care of saving the data and updating the data and all that. Making sense so far? Are you guys following?
Can you repeat that property ref?
Which one?
Property ref.
Property ref?
Attribute.
Yeah. So if it is one to one, if the relationship is one to one, here go back to ebill, ebill.java. Here you have account transaction object, bidirectional, right? And if you go to account transaction.java, you have ebill, right? That means account transaction has ebill, and ebill has account transaction, which is good, which we know so far, right? Then what we are doing here in this ebill hbm.xml is, in this ebill.hbm.xml, we had like um, we had like relationship between these two. Okay, and we said many to one here, but it can be one to one also, doesn't matter. Okay, doesn't matter, just for heck of it, it was many. And what we are saying is we don't state anything in ebill. Okay, all we are saying is only in the account transaction. What we are talking about here in the account transaction about ebill, one to one, like one transaction can be part of only one bill. Okay, one bill. And property ref, that means we are referring the ebill object where it is related to this particular account transaction is using a property ref object. Okay, property ref attribute of one to one. Either you can say property ref and identify the name of the relationship, like within ebill, the property name is account transaction. Okay, within account transaction, the property name of ebill is ebill. Like look at it like attribute names. So all we are trying to say is one to one. How it is one to one? eBill is associated to, okay, this eBill is associated to this one, and how it is associated to the account transaction attribute. Okay, so in the account transaction attribute, like name of it is account transaction. That means think about it like a primary key foreign key query that you write. What you do in the e-bill, you have an account transaction underscore id as a column, and in terms of account transaction table, you have an id. All you do there is select star from account transaction comma ebill, where ebill dot account transaction underscore id equals to account transaction dot ebill. Okay, account transaction dot id. You see what I'm saying? Like the join query. Same way, if it is one to one, we are actually mentioning it as okay, one to one. Ebill is associated to this guy. How? By the account transaction attribute of ebill. Okay, just remember it that way. And how do you specify that? Using a property ref. Is it making sense now?
Yes.
Okay. Setting up relationships. Determine your domain model relationships. Define each as an association or a collection. Identify the multiplicity between the objects and decide on the directionality. Does it needs to be bidirectional at all? It should be the question that you need to ask. And define your relationship implementation types and add interface representation of each association or collection to appropriate domain objects. So create the mappings in the corresponding object mapping files that we know. And if bidirectional, optionally add bidirectional maintenance code. Okay. Collections in domain objects must always use interfaces like collection, list, map, set, etc. and should be instantiated the right way using a like if it is a list is an interface, it should be instantiated using the actual object and stuff like that. Okay. Mapping multiplicity. So if it is one to one, or one to many or many to one, you're going to say like one to many class name, and many to one, you're going to say name of that attribute, id, and the class name, like that. Okay, one to many and many to one. That's how you represent. Many to many. If it is many to many, example, account has many e-billers and e-bill has many accounts. So on both sides mapping collection, you got to say many to many, column account ID, class is this. Many to many, column e-bill ID, and class is this. Only required on both sides if the relationship is bidirectional. Okay, otherwise you need not put on the both sides. Then mapping multiplicity 1 is to 1. eBill has at most one account transaction. Account transaction has at most one eBill. Okay. So if this is the relationship, foreign key exists on the eBill table to account transaction. So in the non-string entity mapping file, one to one, eBill has property ref. We saw this property ref, right? One to one. In the storing entity file, like if eBill, okay, that means if you're storing the eBill, it's like many to one account transaction. Like eBill can have many account transactions, right? That's how it is. That's how it is many to one. It need not be the same combination. On the other side, it can be um, it can be on the it can be on the owning side of the relationship, where we are saying like, oh, okay, how to store it. Okay, owning side of it, how to store it. In terms of account, it is one to one, but in terms of e-bill, it is many to one. Okay, so enforce one-to-one in the database with unique constraints. If storing foreign keys on both sides, use two many-to-one tags. So it's like you will know it once you start executing the example. Let's do that before you get too lost on that. But just to brush up, set is unordered or ordered, requiring value of the column. Map is unordered collection or ordered and requires key and value. List is ordered, requiring an index column on the referenced object. Okay, you guys know this already. Array is a collection. It can hold primitive data types. Bag is also a collection. So no direct implementation available in Java. It is part of Hibernate API. Unordered or ordered collection allowing duplicates. Relies through the collection list. Requires value column and ID bag. Used for many-to-many relationships, same as bag, but with additional identifier column used for surrogate keys. Like in SQL, you'll know what a surrogate key is. Requires an ID generator, just like an entity class. Okay, can be optionally sorted. So let's, without wasting much of our time, probably let's start implementing it. I'm just looking for a UML diagram, so you guys will know entire this case study all about. Then probably it makes more sense. I'm just looking for that class diagram. Did we have the account owner one to many and all that? Did we see that already? Did we see the UML like mapping, right? Did we see the case study of e-bill and everything? Did we see that? Relationships between the tables. Here they showed us some tables, but I think I used to have one slide or something that talks about the case study entirely. Let me see. Maybe I'm missing something in here. Okay. Okay. Let me see if I have one of my slides or something. Just give me a minute. Okay. Okay. These are the diagrams I'm looking for actually. If you look at about it, so class diagrams, I always talk about class diagrams, right? You should really know how it is mapped. Like say for example, that's why design plays a really good role in any of our Java implementations. Before even writing or creating any tables, you got to do these class diagrams, like account owner, how it is related to address, how it is related to zip code. If you remember our initial classes about inheritance, I talked about composition, aggregation, and is a like a whole part relationship, and parent child relationship like inheritance and all that stuff, right? So you should identify your objects, and you should identify your objects and then think about relationships. That when you will understand the ordinality or multiplicity between okay, now think about having relationships between these two entities are nothing but they are the objects in a Hibernate world, or in terms of SQL world, those are the tables that you have. Now you have these objects before even creating. Think about it like how can you relate these two in your business, how these are related. Like this is an arbitrary case study, right? This is an arbitrary case study. In this case study, given a problem statement, you need to come up with all this design stuff. Like, okay, I have an account owner. How scalable it is. Like, I need to accommodate account owners, like their age, their information, their social security, because we got to deal with the fraud and all that stuff, right? So you got to identify all the stuff that needs to be captured and business also may play a role in that. Like business may tell you, oh, we need to capture this data. Then based on that, you create your account owner object, and the account owner's address, you're going to keep it separate. Zip codes you're going to maintain separately. So like that, you need to think about coming up with the relationships and ordinality. Like ordinality meaning multiple, directional, and one to many, or zero to one, or zero to n, those kind of relationships between the entities. Okay, so that's when it makes more sense to you about this example. But let's see. In this case study, we have account. Okay, account object, and we have, if you look at the classes, account is associated to list of registrations, and it is associated to list of account owners, and list of e-bills, list of transactions, and he can have list of addresses. Why list of addresses or set of address, collection of addresses? Is because I can have a home address, office address, and or mailing address may be different and stuff like that, right? So we got to capture all that. So when we are designing, we got to understand our entire module. If you are assigned to one module, you got to understand all the modules. That's when you will come up with various classes. Okay, so you have an account. Account is an abstract class, and we have a checking account, which is a concrete class, right? So that means how each of these accounts are distinguished is based off of check style. That means if a style is savings, then it says savings account. If style is checking account, that means check style is check, something like that. Okay, so that's one. And then account is also associated to addresses, right? Account is also associated to addresses. Then, so these are all from the accounts perspective. Okay, these are all from the accounts perspective. Whereas if you think about it from other models, now you will derive, oh, relationship between other models. Okay, e-bill has transactions, and e-bill may have address as well. Here it is not there, but how other entities are related also, you got to understand. Okay, so that will give you entire modeling of the application, entire modeling of this application. That's when you will understand a lot about it. And uh, okay, you can ask me a question like, okay, now that we are doing all this, but how it used to happen in database, like in the database world. In the database world also, they used to create all this. They used to do it using ER diagrams. Okay, and those are called entity relationship diagrams. Okay, they used to create ER diagrams. Now we no longer deal with the database directly. All we care about when we are dealing with Java and Hibernate is Java objects. So we don't talk about saying anything on the against. So we don't talking about anything against on the anything on the ER diagram. We always talk about classes, class diagrams, inheritance, and all that stuff. Okay, uh, is it making sense? Is it making sense to you guys? This um, why we need to do class diagram and how the relationships are being derived is by creating the UML out of it. Okay. Okay, so let's see one of the samples with this in mind. Okay, with this in mind, let me take a test case which is called account service test in here. Okay, so what it is doing here, like if we save one, if we create the database and save the data, probably you get more used to it. That's why I want to show example first. So we want to create an account. Okay, to create an account, as we saw last week, we get the current session, we create a savings account object, we set all the details to the savings account, and we are saving it. So that means we are creating a savings account object. Okay, once this particular example, this test case is run, you should have a savings account object persisted in the database. Or for that matter, you know, account is an abstract class, so savings account is different from checking account, and both will go to account table. Okay, both will go to account table. But how do you distinguish looking at the account table whether it's a checking account or a savings account, right? How Hibernate knows it, right? So if you look at account.hbm.xml, here there is a column called discriminator. Okay, there is a column called, here we said discriminator, column name is account type. That means you can have n number of account types within a account object, but account type will distinguish between each of these account types. Okay, so how do I achieve that? Using discriminator. Okay, let's see. So you saved it, you saved the account object. Okay, then after that, how do you get the account object? You created a savings account, you need not create if it is already there, and then you create another copy of it. Okay, you're just comparing whether the one you created and the one you fetched is of the same or not. Okay, we did all this last week also, right? And then update account balance. Okay, so what we are doing here, we are creating a checking account, we are updating its account balance. Okay, then deleting account. So we did this kind of stuff last week. Okay, now a little bit more to you is how to test many to many, right? So all this while, okay, we did last week all these examples, but there will be important distinction here. Last week we did not put relationships and stuff like that. We did not look at the data about relationships and all that, right? Now this week we are going to look at the relationship data, like account may have addresses and stuff like that, right? Account may have e-bill data, all that, how to set that data and how to refetch that data, all that we're going to see in this examples. Okay, so if you see here, test many to many, like if you want to see how many to many works, okay, you're going to create an account owner 1 and you're going to create an account owner 2. Okay, so account ID has an account owner 1 and account 2 also has an account owner 1. Okay, that means same account owner, me, has both two accounts. Okay, I have two accounts and we saved both. Okay, we saved account 1 and account 2. Fine. Now load the account owner and ensure the count of accounts are correct. Now I should have two accounts, right? So now I fetch the account owner. Okay, I fetch the account owner and I should get the accounts, like account owner dot get size. See here, I will just say get account owner and I also got account object within that. You see what I'm saying? So I just said account owner, right? Account DAO dot account owner. What I'm saying here, session dot get account owner object. That's all. But it fetched me account owner and accounts also, list of accounts that he's associated to also. That's where these associations comes in handy. You see what I'm saying? Let's execute it. Probably then you guys will appreciate the concept. What I'm trying to do is I'm trying to comment out everything else. Okay, I'll just execute. Sorry about that. I'll just execute only this one. Let me see. So we got to look at our hibernate config.xml where we have all our data correct or not. Oh, it's correct. Database. What is the database that we created last week? Do you guys remember? I think it is what? Training? No. Lecture one, right? Tables. Yeah, we have these tables last week we created. Okay, let's see. Okay, so these are the tables. Okay, so let me just modify it to my database table, database username and password. Okay, it's all MySQL dialect. If database doesn't exist, don't create it. Every time it creates it. You saw this, right, last week? I need to see the SQL formatted. Okay, fine. Let's go ahead. So all this is there. Let's just try executing many to many. Then you will appreciate it, right? So right now, before that, let's actually drop all the data that we had. So we had bunch of data, right? We had bunch of data. Let's just clear off all the data that we have. Okay. So I'm just truncating this table. Okay. Oh, okay. It has a foreign key. Some other data is also there. Account is there, and where else it has a foreign key? Somewhere there is a relationship, it seems. Okay, I'll just delete uncast. Okay, so I deleted all the data. So now we have clean slate. Okay, let's see. Okay, let's do it now. If you guys are able to see it properly. Okay, let's see that. This is when all the magic happens, right? It looks at all the config files, it reads the mapping file, and it checks if the database exists or not. Some error happened. Let's see what's that error. Okay, so what did it say? I gave the incorrect database property. So let's go look at it here. I gave SPB user, actually SPDB user. That's why it failed. Okay. So it's trying to establish the connection. Looks like it established. This time no error. Schema update complete. Did you see that logger here? Schema update complete. Okay. Then I go inside create account. Okay. So it's creating an account owner service. It's building the account owner with the SSN number that we passed. Okay. So we are creating account owner. We're creating some address, zip code, and everything. So all we're creating is account owner first. Okay. And we persisted the account owner. Okay. Look at it. Insert into account owner. That means we have an account owner created by this. Okay. In the same way, we are creating another account owner. So each account owner is uniquely identified by a SSN number, right? SSN number is unique. Fine. Now we have build a savings account. Okay. So what we are doing here is created the savings account. Savings accounts have the interest rate, right? Checking account doesn't have it. So we added an account, and we added the same account owner one to this savings account. and we created another savings account, and we added account owner 1 and account owner 2 to that account. Okay, that means account 2 is a joint account, account 1 is a single account. If you look at account owner 1, you should get 2 accounts listed. If you look at account owner 2, you should get only 1 account, right? Fine. Now when we are saving save or update, okay, when we are saying save or update, it is actually saving only the account, right? Okay, we are actually saving the only save or update. Okay, before even executing commit, let's execute all. Let's see what do we have in our database. Okay, I'm just closing all the tabs. So let's see what do we have in accounts table. We don't have anything. How come? We should have it, right? We don't have anything in the account e-biller. We don't have anything in the account owner because we did not execute commit till now, right? You follow? Okay, so let's execute commit and see. Okay, executed commit, and then let's see what is there in a account. See, we have 2 savings accounts we created, and look at account owner object. We created see 2 account owners. Okay, 2 account owners and their ID. Okay, account owner data. Fine. And where is actually account and account owner associated, right? If you see, this is the account. Okay, and look at the account table. Account table has account ID and type and stuff like that, right? So where is account owner and account relationship mapped, right? Where is account and account owner relationship mapped? It should be in this join table. Do you see that? Here, like, because we set all the data, here also it's been persisted. Like, we did not explicitly say persist in account owner object, right? Did we say that? We did not, right? All we said is do a join one to one. This is one to many and that is one to many, so it is many to many, and it created a join table. And see here, if you look at account ID here, you have 2 accounts, 2 account owners. Okay, 2 account owners and their account owner ID. Account owner ID is the primary key for this table. We don't need to worry about it. So here all we care about is given an account ID 15, you get 2 accounts. Given an account owner ID 1, you get 2 accounts. Okay, so that means given an account ID, you should be able to get the account owner and all that stuff, right? Now let's see. With this in mind, now let's see. Let's do a get. Okay, when you get account owner 1, okay, when you get account owner 1, look at the SQL very carefully here. Okay, when you get the account owner 1, you are getting select account owner, all this account owner ID. That select query is being executed. Okay. And this select query has been executed. Okay, see here now, when you're actually fetching dot get accounts, that's when it is firing a join query. Do you see what I'm saying? It is writing a join query for us when you are actually fetching the account dot get owners, right? Until then, it fetched only the account, right? Like if you say get account owner, you saw only getting the account owner previously, right? It just fetched only the account owner. It did not do any join here. If you look at this query, if you look at this query, it just fetched the only account owner. It just previous one also fetched only the different account owner, because we were asking for fetching only the account owner, right? But when we did account owner one dot get accounts, what did it do? It fired a outer join between account owner table, account owner, okay, and account. So based off that, it fetched us the list of account owners associated to this account owner ID, right? List of accounts associated to this account owner ID, like that. It did a join, right? It did a join for both. Okay, but when we are fetching, okay, let's fetch accounts again. Okay, previously we fetched account owner and we said get accounts. Now we are fetching only the accounts. Okay, now we are fetching only the accounts. See here, because account is already fetched before, right? Did we fetch accounts before? We did not, right? Okay, that's fine. Okay, so now see what happens. Account owner dot get account owners. Account one dot get account owners. So now it fired a query saying that join again, like account owner and account owner. Okay, so given an account ID, it fetched account owners. Okay, it wrote a join to fetch the account owners associated to that account ID. Okay, okay, for each of these. And now you're asking for account owner's address. If it is a different table, it will fire that query as well. See here, it did a big join query for all the states and all that. Street address has this, where this. So it does a bunch of stuff for you to get the data out of it. Okay. So all I'm trying to say is when you persisted, it persisted on its own based on the mapping that you created. And when you're fetching, it is fetching on its own based on the mapping that you have created. Okay. So this is where joins are important. Maybe now join why these associations are related and all that stuff made a little bit sense to you probably, right? Are you clear now? Like what exactly is happening behind the scenes? When you mapped it, it actually created like the join table, and based on that join table, it actually fetched the data and stuff like that. Is it making sense?
Yes.
Any questions? Any questions on this? Now, if I execute the rest of the flow, all the data will get deleted. That's why I may actually terminate it here. Okay. Any questions? Now you get the feel of relationships, right? Relationships between objects. Uh, any questions? All right. So that's that. Okay. And then so similarly execute other queries as well, like e-bill fetching, how the fetching works, like create multiple e-bills. Okay, you created multiple e-bills associated to an account. Okay, associate to an account, and then you are fetching an account. So when you fetch an account, you should be able to get the e-bills also. Okay, because you associated it and persisted, when you're fetching it also, it will come back. Okay, and then create multiple account transactions. What we are going to do here is create a checking account, and once the checking account has been created, we are creating 10 transactions within that. Once that is all done, we commit it, and when you fetch an account, you'll get all the list of transactions. Okay, fine. And account inheritance, like see here, you created a checking account, savings accounts, 3 savings accounts. So five accounts get created at the end of it. So now when you say account service dot get checking accounts, here what we are doing here is accounts dot get checking accounts. All we are saying is Okay. Criteria, checking account dot list. Okay. And get savings account, you're just saying like savings accounts dot list. How does it know whether it's a checking account or savings account? Based on the discriminator column. Discriminator column is the type. That means um, in the account, okay, in the account object, you have a list of all this, okay, list of all this. And probably when we saved checking account, we are saving type also, right? Let's see how we are doing that. Like here, select accounts. So we have account type. How is this account type getting persisted? Right? Go to account.html. Account type is a string discriminator. But who is loading the discriminator? See here. We say okay, savings column and check style. Check if the discriminator value is checking. If the discriminator value is savings, we put different columns here. But who is giving it a discriminator value? Did you guys have the same question as me? Who is telling it the discriminator value? Right? Who is telling it the discriminator value? Let's see. Discriminator is account type. Polymorphic data requires a column holding a class discriminator. This value is not directly exposed to the application. Okay, not directly exposed to the application, but somebody should be setting it, right? Otherwise, how it is getting saved? Let's see. Account owner service. What is our test case name? Let's go ahead to our test case. This is our test case. Okay. When we are saying checking account, we are saying build checking account. We said check styles, checking object. Okay, all good so far. Date, check style, and all that. So till here, no value being set. Create account. So it just updated it here, right? So did you get it? Like how it is coming along? Probably this one. Like if an object has interest rate, okay, set, then it is called savings account. If an object has check style, okay, check style as a property, then it is a checking account. That's how it is discriminating. So Hibernate is taking care of it to set either savings or checking. We are not setting it in the code, okay? But now, interestingly, if you end up creating another subclass, did you follow what I just said? Like the discriminator column is taking care of it, right? So if I create another subclass of it, okay, no type class, and look at checking account, and I will not create any check style or anything. Okay, I'm not creating a check style. And in our this one account, some test is there. Yeah, account service test. I'll create one more method called so basically if we don't pass both, will it save or not, I want to show. Okay, like no type has a no discriminator column set, right? Any property that it is looking at is not there. So let's see how it's going to be here. Okay, okay, build no type account, this. Okay, let's try and save it. I just want to create it as a different one. Okay, okay, let's see if it actually persists anything. Okay, unknown entity because it doesn't know it. Okay, we can add that unknown entity. That's not the error because it says unknown entity account.html had these two. So here we got to say anyways, like if it is empty, let's see. Yeah, if we were to save it, we got to tell it anyways. So it's going to be another string. So it doesn't let us save it until you mention it anyways. So yeah, once you give a discriminator column, yeah, it's of no use. I wanted to test without giving discriminator column, but I think that's okay. So it's just no property. Okay. So I don't have any other property, right? If I don't have any property, So I defined it anyways. So I didn't want to define it. If I don't define it, it will not know. That's the problem. So that's okay. Like if we just run this, probably it will insert now with a null value of it. Yeah, it inserted. So yeah, that's about it. Like if you look at our account, now there is one without an account type also. But yeah, if you don't tell the entity name, like a new class object name, it will not recognize that. So that's why we couldn't do that. Okay. So that's how for different types of things, you have to keep adding whatever account type that you want to the XML file. Okay, that's fine. And let's see what else we can discuss in here. Account inheritance we know now. Okay, so what is it here in these examples? Okay, so we got the session and we got the checking account. We created a commit and then we open another session and we got the same account that we created in the past, and we were looking at the balance. So balance we are comparing, which is all fine, and we committed. Now change the flush mode to manual and confirm that the update does not occur when the transaction commits. Okay, so what we are trying to do is we are trying to set the flush mode to manual. Actually by default it's probably auto. Okay, by default it's probably auto. Flush meaning it is actually writing. That's when it actually writes. Okay, if you don't specify anything, commit will invoke flush mode auto. So that's why it will commit. Otherwise, you got to actually invoke a flush. That's well probably it will write. Let's see. So change the flush mode to manual and confirm that the update does not write the occur when transaction commits. That means after this commit also it will not write. Then make sure we just once we just pulled back from the database does not have the updated balance. So this is what we're trying to do here. All we're trying to do is flush mode by default is auto. So update is changed when the transaction commits without an explicit call to the save. Okay. Whereas all we are trying to do is within the transaction you need not explicitly call save. The reason being this will get committed automatically. Are you guys with me? Here you need not explicitly call session.save. Do you see that? Within a transaction, once the transaction is committed, if all these entities are managed entities, it will automatically commit the transaction. You need not have to deal with it. Getting it so far? Yeah.
We have to write commit, right, Ruby?
Say that again.
We have to write commit, then only it will execute.
Yeah, but my point was a little different. Not about commit. I'm talking about save. You will not specify save. You're not calling a DAO to save it. Here, you created an account. You updated the balance. Then you need not save it. It gets automatically written. That is my point. Do you see that? We created an account.
Yes.
Database transaction is written. We invoked save there. Good. But after that, we did not do anything. We just updated this. And as flush mode is auto, it writes it to the database directly with the commit call. You need not have to explicitly call a save or update. Whereas here, you get the account. Okay, you're just making sure whatever you have written is there or not. and then you explicitly set the flush mode to manual. When you do flush mode to manual, you modify something and commit, it will not get written to the database. Okay, and flush mode auto will take care of it, or flush mode commit will take care of it. Default is auto, and then flush never will never write to the database. Okay,
If you write save here, will it be saved to the database?
I think so. That's where I'm getting into next. In this flush mode, account dot, that is what is manual, right? Here, okay. So let's test once without and then once with. Okay, so let's execute this. Okay, okay, I'm just trying to see. Okay, so I created an account, save. Okay, it invoked update query by default. Did you see that? It writes the update query on its own when you do a commit. That's why we see it in the database. Now let's check if it is matching what. So asserted true. That means assert is to actually check. Okay. Now flush mode manual. You had a balance of 5,000. You invoked a commit. Nothing happened on the database, right? Invoked it. Begin transaction. Get the transaction. Balance is 2,000. Fine. See. Okay. Let's not delete anything. Okay, that's fine. Let's delete it. Now I want to execute the next one. Okay, it created accounts, did the update and all that. Cool. And then this is all fine. Okay. Now is our manual step. Okay. So it did not write anything. You see, yeah, it did not even do when we did the manual save or update. Let's see. It is still 2000. Okay. So let's go to hibernate flush mode manual. The session is only ever flushed when session.flush is explicitly called. See here, not during the commit or explicit save. So just before this, we should call session.flush. That will spill over. Like even in IO we saw like a writer.flush. That's when it actually spills out to the file or a database. Let's see. Okay. Okay. Now it involved the update. Now this assert will fail. Yeah, it's 5,000. Okay. Yeah, assert failed. Okay. So this is about the flush mode. Okay. Then comes anything else in here that we are missing. So this is all about mapping we saw in here. Okay, let's look at other test cases too. We had like 3 test cases, right? Service test has one. It's just creating an account and all that. So unit test cases are very important and tough to write as well. Like it is making your code testable. Like you claim it is working, you got to prove writing test cases that your code is working. That's why you do this unit test cases. Okay. Now let's see e-biller test case a little bit. They're like couple. Um, Creating an account, creating an e-biller, and you're building an build e-bill. What is it trying to do? So it is trying to do e-bill, construct an e-bill with the e-biller and also the account that it is associated to. Fine, we got the e-bill, and then e-bill service save or update e-bill. This actually creates a join probably. Like let's see, save or update e-bill. It's going to save. Okay. So let's just execute the first one, and then we're saying like pay e-bill. What we're trying to do, create an checking account, create an e-bill, and associate it to a transaction. Once all this is done, we're persisting the e-bill. So let's see, like, so it is touching multiple tables. Let's see how it is behaving. Okay, here is the, okay, begin transaction, create a checking account. Okay, created the checking account and inserted a checking account. Let's see that. Okay, just inserted just now at 8:01. Nothing at 8:05. Okay. Because it did not write to the database here. So e-biller and then build e-bill. So it's associating the e-biller account and e-bill. Okay, so let's see. save, and okay, now we close the session. So here we should see one more entry at 8:05, yeah, and then we have an e-biller. Okay, it's actually discover card. Okay, so this is the one, e-bill. Now e-bill has association of e-bill related stuff and e-biller ID. Do you see that? E-biller ID and account ID, because we associated it in here, right? While constructing an e-bill, we passed an e-biller ID and account ID. Okay, so e-biller ID and account ID, everything has been set. Okay, now if you see, there is no entry in here because this is not we were touching. We were touching e-bill, e-biller, and account. Let's see, and then we are talking about only e-bill here, not the account. So when you say check the IDs were set after the HBM session, like we created an e-bill. Like let's look at the hbm.xmls of e-bill. Okay, e-bill.hbm.xml, and which one did we try saving here? E-bill only, right? So let's see. When you're saving e-bill, what all you need? E-bill ID. So e-bill has like these three as composite primary key. What is a composite primary key? If you have more than one combination of more than one unique key, like more than one is an unique key, like account, e-biller ID, account ID, e-biller ID, and due date. If these three are only unique in your table, then you put the composite primary key. Okay. Um, if account ID itself is not unique, because in this combination of e-bill, an account ID can have multiple e-bills, and it can be billed by multiple e-billers. Okay, so yeah, that means duplication of rows can happen. All it varies is at what instance of time it has been created. So that's why we put the combination of like, okay, account ID 1, e-biller ID mastercards, what's the due date? Like if you are creating a e-biller service, this is what is your entity. Okay, so account ID, e-biller ID, and the date. And later you need a minimum amount, balance, and all that, just as any other bill. And it also needs to create no transaction. See here, it also need to know transaction. And here, let's see what happened in the account transaction table. Once we saved it, nothing happened, right? Nothing happened in the transaction because we did not set any data, I think. Let's see. And then we need e-biller ID and account ID. We passed these two, that I know. But here, we are also saying insert equals to false. Did you see here? Okay, update equal false. That means when something is modified in e-bill, we didn't want any updates to happen to e-biller and account. That also we can control. Okay, if those actually, if you did not put this, if this data doesn't exist, it is going to insert a new one. Okay, it is going to try inserting a new one because you controlled it. It is not inserting anything here. Okay, must have an insert equal to false, update equal to false, because IDs for the objects are part of the composite key. The relationships are managed via the composite key elements rather than the many to one relationship elements. Okay, and now here many to one. This many to one is many e-billers are associated to an account transaction. Let's see what is this table doing for us. E-bill table, right? It didn't have an account transaction because we did not set it. If you look at our code, e-bill service test, it did not we did not set anything to bill. Like we set only the e-biller details, not the transaction details. That's why it was not there. Okay, if you would have set transaction, the transaction ID would have been there as well. Okay, so it depends on whether the data is being passed or not. Nothing new in here, just that No, you can configure composite primary keys also. That's the only takeaway from this sample. Let's see here. You have a checking account, you created an e-bill with the account passed into it. Now we are passing account transaction also. Let's see how it will be. So we created an account transaction, we set the transaction to e-bill, and we created an e-bill. Okay. So once this is done, probably let's see how it looks like. Okay, see a new e-biller is being created with a transaction ID set 1. And because previously transaction table we saw has no data, now it will have data as well because we created a transaction before associating to it. Okay. Okay. So we did not touch account e-biller because here we were only creating the account transaction with an e-bill and we were saving the e-bill. That's all. Okay. Okay. In the e-biller service, probably data goes here. Okay. So it's all based off of, forget about e-biller. It's all about any entity that you're dealing with, any relationships that you're setting, get saved, and you should be careful when you're saving it, whether you want to update the relationship table or not, or whether you want to fetch the relationship table or not. Depending on the situation, you should be able to configure and tweak, okay, what you're doing. Making sense? Any questions? Any questions that you guys have? Okay. So this is another test. Just try executing it. If you run into any issues, let me know. Okay, fine. So that wraps up this part of associations, and let's see if there is anything else that we need to cover today. Yeah, this has many to many actually. Like just like our account owners thing. You create these. It is just simple. Many to many. But look at the HPM.xml stuff here. So you have a class, okay? You have property, you have list of e-biller registrations, and how do you map list of those? By passing an e-biller ID. Like e-biller ID is associated to e-biller registration. Like let's see how it is in the. This is the relationship between e-biller and e-biller registration, right? Let's see e-biller.java, okay, and e-biller registration.java, okay. So see here, e-biller registration has a e-biller registration ID, account, e-biller object, account number, date added and registered by. So this is like e-biller registration. Like if you are trying to register one of your accounts to Mastercards or something, some billing service, then you have to do this registration. Fine. So to that, if you see here, an e-biller can have list of e-biller registrations. Okay, that means one e-biller can have n number of registrations associated to various people, right? And then you can generate n number of e-bills for those guys. Okay, so that's the relationship. That means think about it like I have a e-biller. I have a e-biller service. Okay, like e-biller service, and that e-biller service is taking n number of registrations, like from various companies or something like that. And those companies are giving me data about various people. Fine. I registered them and everything. Now, what I need to do? I need to generate bills, right? So that means I need to have registrations. For e-bill, should have set of registrations. Collection is nothing but a bag here, which can allow duplicates and sorted set. And then, like this is the output. Once you register these guys, this will be the output. Okay. So um, more than that, relationship between these two. Okay, relationship between these two. Let's look at the XML file now. So you have a e-biller, you have name, billing address, phone, and all that. You have a bag of e-biller registrations. set of these things. Okay, how are you configuring bag or set? This is how you configure. Like you give the name, whether this guy is owning the site or not. You specify by inverse property, and key, like how you map e-biller registrations to e-biller ID. Okay, and not null true. Then one to many, like with one e-biller you can have many e-biller registrations. Okay, in the same way you have a set of e-bills. It is one to many, like one e-biller can have n number of e-bills. Okay, so all you care about is inverse attribute and stuff like that. If it is bidirectional, you got to look at there as well. Like in the e-bill, how are we mapping to e-biller, right? In e-bill.html.xml, how are you mapping to e-biller? You're mapping it many to one, e-biller ID, this and stuff like that. Okay, but look at e-biller.java. This is what this is e-bill, right? Okay. Look at e-bill.java. You don't have a collection here of e-bills. One e-bill is associated to only one e-biller. That's why you don't have a collection here. Making sense? Making sense?
Yes.
Yeah. So this takeaway from today's session is you should be able to identify the one to many, many to one, okay, and all that stuff, and many to many. So all this takes care of those only. Like it talks in detail about what the examples that we saw each and every one. You got to be a little more careful when you're having a bidirectional relationship, whether to update the relationship or not. Okay, fine. So this talks about relationships. Okay, fine. So we learned about relation associations and between entity classes and collections. Looked at the way Java and databases realize relationships. Walked through the ways to realize relationships with Hibernate. So some Hibernate recommended approaches using the intermediate object to realize many to many. That's the intermediate object is nothing but the join object. Okay. So any questions? If you were able to, like, if you are comfortable with these, that means we met our objective for today. Like this is what we need to understand. Okay. Any questions on these objectives?
No.
Yeah, go ahead. Any questions?
No.
Did you guys follow? Like, got a sense of what is one to one, one to many, many to one, and many to many?
Mm.
Yeah. Okay, fine. With that being said, let's see what else I can show today. Okay, so in next one, understand the difference between a component and an entity class. Learn how to map components. Walk through ways of realizing inheritance and stuff like that. Okay, so let's see that in our this one. I'm just thinking whether I should start or not. Let me see, like how many else we have. We have persistent session management. Okay, what I'm going to talk about in the session. JTA. Okay. Okay. We may be actually running one more week on this. Okay. Yeah, that's okay. So I'll probably start this fresh for you guys next week because um, this may be overwhelming to you. Like, get comfortable with Hibernate. Probably tomorrow I'll start this session of yeah, this one, component and inheritance mapping, and probably we'll target for these two tomorrow. Okay. but be comfortable. Try running the examples that I'm giving, so that makes you guys probably feel a little bit comfortable. It's my thought. If you don't run it, you get a little bit scary once we move to the next sessions. That's why I'm going slow a bit. I could start this one otherwise, but I didn't want to. I'm not sure whether you guys started Hibernate. Like, did you finish JDBC and move to Hibernate yet, or no?
Finished JDBC.
Finish JDBC. Yeah, get comfortable with Hibernate as soon as you can. So probably then you will not be like overwhelmed, and I can continue with the rest of the sessions with thinking like you guys are with the same page as me. Okay. Okay, then we'll meet tomorrow. I'll start